In this section, we're going to talk about terms, like terms, coefficients, and constant, just to get comfortable with some of the vocabulary. We're going to apply the distributive property, including with negative numbers, and then we're going to use the distributive property to simplify an expression. So to start, we're going to talk about the basic distributive property, and what that means is when you distribute, you multiply. So in this example here, the thing that's being distributed is the A, and it's going to be multiplying both the B and the C. So one thing that can be helpful is to draw the arrows, kind of showing that you're making sure you're connecting the A to both the B and the C. And then the arrows can just be a helpful reminder to people that you're multiplying. And so your final answer would be whatever A times B is, plus, because it's a plus, A times C. And then you could have a similar kind of problem like down here. So again, because A is stuck to the parentheses, you know that means multiplication. And here the A is also stuck to the parentheses, so it also means multiplication. You can just do it even though it's on the opposite side. You'd still end up with AB plus AC. On this example here, the only difference is that separating B and C is a minus. So this time when you multiply, when you separate AB and AC, you separate it with a minus sign. So for the first example, we would just make sure that 4 multiplies both the y and the 3. And so 4 times y is 4y, plus 4 times 3 is 12. And that would be our final answer, because 4y and 12 aren't like terms. We'll talk about that a little bit later, but because this guy has a y and this guy doesn't, we can't add them together. In the next example, we're going to distribute the y on the outside to both pieces on the inside. So the first one, y times y, anything times itself means to square it, so that would be y squared, plus y times 7 would be 7y. And again, not like terms, so that's going to be our final answer. So you're going to pause the video, try these 3 examples right here, press play when you're ready to check your answers. So in this first example, we have n times n, which is n squared, minus comes down, n times 9, which is 9n. This example, again, you want to make sure you're being really careful about order. So you're first doing 8 times 2, which is 16. You bring down your minus, and then 8 times n, which is 8n. Keep in mind that that would be extremely different than 8n minus 16. Remember that subtraction is not commutative like addition. You can't just switch the order. And if you look here, that's a positive 16. There's nothing in front of it. Down here, this is actually a negative 16 because you have the minus sign in front. So the red and black would be completely different. So it's really important that you're going in the order that you're given. You just kind of want to work left to right here, and you'd end up with 16 minus 8n. Here you're multiplying 1/2, so 1/2 times 2 is 1, so you'd have 1n plus half of 6 is 3. Another way you could write this would also just be n plus 3. You don't need the 1 in front of the n if you don't want to. So on these kinds of problems, the main difference is that now we're just distributing a negative. So it doesn't really change how you do it. You're still going to multiply. You just want to make sure that you're following your positive and negative rules. And the other thing is you may want to do keep change opposite inside the parentheses with subtraction before you start. So this first one's pretty straightforward. You just multiply negative 2 times x, and you get negative 2x. Bring down the plus sign, and then negative 2 times 7, a negative times a positive is a negative. That would be negative 14. On the next one, before I start, I'm actually going to change 5 minus y to plus negative. And now I'm ready to distribute, so I'm going to multiply negative 3y times 5. So that would give me negative 15y. I've changed the operation to plus, so I'm going to bring down a plus sign. And then I'm going to multiply negative 3y times negative y. So I have a negative times a negative. I know my answer is going to be positive. And I'd have 3y squared. Would be my final answer. On the next example, because there's just that negative sign out front, I really don't know what's being distributed. Here I was distributing a negative 2. Here I was distributing a negative 3y. Here I want to think of that as a number, so I'm going to think of it as a negative 1. So I'm going to put a negative 1 inside. I'm also going to rewrite my subtraction as adding a negative. And now I'm ready to distribute. So negative 1 times 2x is negative 2x. I bring down my plus sign, because that's what I changed it to. Negative 1 times negative 11 is positive 11. So now we're going to start getting into some definitions. So first we're just going to start with the basics. What a term is. A term is going to be a piece of an expression separated by a plus or minus sign. So terms aren't separated by multiplication or division. They're only separated by plus or minus. So In this first example, I have a minus sign here, a minus sign here, and a plus sign here. So that separates my terms from each other. So my first term would be 3x. My second term, you just have to be really careful, is actually negative 4, and you can either attach the minus sign or you can change it to plus negative. My third term would be negative 6 again, or negative 6x. I would change it to plus negative, and then my fourth term is 2. So in that example, I actually had 4 terms, and you want to be super careful with the signs of each term. So a coefficient, that's our next vocab word. The coefficient is going to be the number that's multiplying the variable. So coefficient is going to be a vocab word that you hear a lot this year. It's definitely something you want to be aware of. What's important about a coefficient is that a coefficient is just a number, but in order to have a coefficient, you need a variable, because you're going to have a variable, and then whatever's multiplying it is your coefficient. You don't list the variable when you list the coefficient. So for example, down here, I have a variable x. The number multiplying it is 3. So the first coefficient would just be 3, because that's the number multiplying the variable. I also have a variable here, I have an x, and the number multiplying it is negative 6. And the reason it's negative is because there's a minus in front, or you can rewrite it as plus negative if it helps. Constants are pretty straightforward. The word constant means it can't change, it always stays the same. So in math, the easiest way to have a constant is it's just a number, because numbers aren't going to change. But what's important is there's no variable, because variable by definition means it can vary or change. Constant means it can't, so constants are just the numbers that are all by themselves. So in this problem, the numbers without variables are negative 4 and 2. Those are my constants. And then like terms is going to be terms with the exact same variable piece. So that means if something has an x, to be a like term, it would have to be just an x. It couldn't be xy or it couldn't be x squared. They have to match exactly. So our first set of like terms in this problem are going to be 3x and negative 6x. And again, remember it's negative because it's a minus sign in front. And then my constants are also like terms because they're just numbers. So negative 4 and 2. And what's important about like terms is you're allowed to add them together or subtract them from each other. You can only add or subtract items or terms if they are like. And that's what we're going to use going into the next set of examples. So down here it says to simplify. I'm actually going to start with this example over here, so then you can do these two on your own. So we're always following order of operations. Anytime we have more than one step, we always start with order of operations, which the first thing in that would be parentheses. So in my parentheses, I have n plus 9. But I can't add them because they're not like terms. Their variables don't match. And in here I have 2 plus n. So I can't do parentheses. I have to move on. I would then move on to exponents, but I don't have any. So then I would move on to multiplication. And I do have multiplication. I have multiplication here. I have 4 multiplying. And I also have multiplication here. So that's what I'm going to do next. So the first thing I'm going to do is to do this multiplication. I'm going to do the distributive property. So I end up with 4n plus 36. Here's where you want to make sure you're really careful. So here I knew it was a 4 that was doing a distributing. The number that's doing the distributing here isn't just a 3. It's actually a negative 3. And the easiest way to make sure you do that is to change it to plus negative. So now what I'm going to do is I'm going to bring down a plus sign, because that's a plus, so that's a plus. And now I'm going to distribute my negative 3 to the parentheses. So I have negative 3 times 2 and negative 3 times n. So I end up with negative 6 plus negative 3n. If you didn't change this to plus negative, you'll probably get the negative 6, but you probably wouldn't get the sign of that correct. So my suggestion is anytime you have subtraction, change it to adding the opposite or adding a negative, and then distribute. So now I just have 4 terms, 4n, 36, negative 6, and negative 3n. And now I'm going to combine my like terms. So I have 4n and negative 3n, which I'm allowed to add because they're like terms. So to add like terms, you just add their coefficients. So I'm going to add 4 and negative 3, which is 1, so I have 1n. You could also write that just as n. Plus, my next set of like terms is 36 and negative 6, which adds to 30. They're not like terms anymore, so I'm done. So my final answer is 1n plus 30, or you could even say it's just n plus 30. So you're going to pause the video, try these 2 examples right here, press play when you're ready to check your answers. So in this top example, first we distribute a 2 to get 2x plus 16, bring down our plus sign. Then you distribute your 4 to get 4x minus 12, and then you combine your like terms. 2x and 4x add to 6x. 16 minus 12 would be 4 for a final answer of 6x plus 4. Here I distribute my 8 to get 8x plus 24, and notice I changed it to plus negative 2 before distributing. So I'm distributing a negative 2 to get negative 16 plus negative 2x. Then I combine my like terms. 8x plus negative 2x is 6x. 24 plus negative 16 is positive 8. So now we're going to get into some word problems, and we're going to start by writing a variable expression to represent the total number of calories that we burn if we run and swim. But the key is that we can only use one variable, and that variable is r. So that's what's going to be a little bit hard. But we're going to assume that we're running and swimming, but we're only allowed to use r, which stands for how long we run. So the information that's important is that we want to work out for a total of 50 minutes, and we can get to that 50 minutes by doing both activities. When we run, you burn 15 calories per minute, and when you swim, you burn 9 calories per minute. So again, we're only going to use r. So the way that you want to start by thinking about this is that the total amount of calories that you're going to burn is going to be the number of calories from running plus the number of calories from swimming. And the way to figure that out would be, you first would need to know how many minutes you spend running, and then how many calories per minute, and you would multiply those two things together. And then we're going to add. Same thing for swimming. We need to know the number of minutes we spend swimming, and we'd multiply that by the number of calories per minute. So the good news is the problem actually gives us some of this information. They actually tell us for running, they tell us how many calories we burn per minute running, which was 15. And then they also tell us how many calories we burn swimming, which is 9. The thing they don't tell us is how many minutes of each activity we do. Now we know we do 50 minutes total, but we don't know exactly how many of them are spent running or swimming. A lot of people think, oh, 25 and 25. It doesn't say that they're split evenly. It could be 50 of one, none of the other, 40 of one, 10 of the other. The thing is, they don't tell us. But what they do tell us is r, and they say that that's the number of minutes that you run. So even though we don't know the number of minutes that we run, we're going to use the variable r in its place. So now I have this expression that would help me. If I knew the number of minutes I run, I would take that amount multiplied by 15, and I have the total calories I burn running. Here's where it gets a little tricky. It tells us to base only on r. So what they're saying is only use one variable. I don't know how much time I spend swimming, but I do know two things. I know that I spend 50 minutes total, and that r of those minutes have been spent running. So if you wanted to figure out how much time would be left over for swimming, you would subtract. You'd take the total amount of time, subtract the running, and you're left with swimming. So that's what's going to slide in here, 50 minus r. So again, the number of minutes you spend swimming is 50 minus r. The number of calories is 9 per minute. Over here, the number of minutes you spend running is r. Calories per minute is 15. So I'm going to take this expression right here, and I'm going to simplify it. So I'm just going to move over. So right now I had r times 15, so I'll make that 15r. This is my calories from running, and I'm adding to that my calories from swimming, which I get that by doing the number of minutes I swim, 50 minus r, because total minutes minus the running, and I'm going to multiply that by 9, because that's how many calories I burn per minute. So then I'm going to distribute. So I have 15r plus 450 minus 9r, and then if I combine like terms, 15r minus 9r is 6r plus 450. So here's my expression that can represent the total amount of calories I burn if I run and swim for a total of 50 minutes. So that's the expression that I'm going to use. So now down here it says, what if you run for 20 minutes? So again, I'm going to use 6r plus 450. And now it tells me how many minutes I'm running. It's 20. So I'm just going to replace r with 20, which gives me 120 plus 450, which is 570. So if you run and swim for 50 minutes total, and 20 minutes are spent running, you should burn a total of 570 calories. I got this answer by plugging into my answer for part A. I could also check that using common sense. So I could just go back to the basics in the problem. So, okay, if I spend 20 minutes running, and I know that I'm burning 15 calories per minute, that would be a total of 300 calories just from running. Then don't forget that you're swimming. And so if you ran for 20 minutes, that means you're swimming for 30, and they're at 9 calories per minute for a total of 270. And if I add those two together, I would get 570. The fact that if I do it this way and I do it this way, both give me an answer of 570, means that my answer to part A has to be correct. So in this problem, you're giving 1 hour saxophone lessons. You're giving it to 20 students each week, and those students can either be beginner or advanced. Beginner students cost $20, and advanced students cost $35, or that's what you charge them. So we're going to write an equation to represent your total weekly earnings, y, as a function of x, the number of beginners. So what's important is that you want to only use this variable x for beginners. And it says to write an equation to represent y, so I'm just going to start it for my final answer. I'm going to have y equals. It's going to be my final answer. But I want to think about this as, let's say at the end of the week, you have this big pile of money. So a big pile of money at the end of the week. If I wanted to, I could separate this into two smaller piles of money. And the way that you get the big pile is by adding these piles together. Now this pile over here represents all the money that I made off of my beginners, and this pile over here represents all the money that I made off of my advanced students. So if I can figure out the beginner money and the advanced money, and I add them together, I get all the money, which in this problem we're calling y. So to figure out the money that you'd make off of beginners, you need to know two things. You need to know the number of beginning students and the cost per beginner, and you would multiply. And we're going to add to that the money we make off advanced, and to find that, I would need to know the number of advanced and multiply that by the cost for advanced. And the problem gives you some of this information outright. You know that the cost per beginner is $20. You know that the cost for an advanced student is $35. We know that we're going to be adding our money from beginners to the money plus advanced. What's missing is how many of each type of students we teach. So they tell us that we teach 20 students in total, but we don't know how that breaks down. It could be all of one, none of the other. It could be 10 and 10. It could be 5 and 15. We don't know how many beginners of these 20 students, or of these 20 students, how many beginners and how many advanced. Then they also give us this variable. They say to use x, and that x is going to stand for the number of beginning students that we teach. So right here where it says number of beginners, I don't know it, but they told me to use x, so I will. And then instead of x20, I'm just going to write it as 20x. It'll look a lot better. So now the really hard part is that I don't know the number of advanced, and I'm only allowed to use the variable x to try to get there. So x of the students are beginners, and I'm teaching 20 students total, so that would mean my number of advanced is the total number of students, which is 20, minus the beginners, which is x. That would be my number of advanced students. And the reason I'm multiplying that number by 35 is because the advanced students, which is 20 minus x, cost $35 each. So again, $20 per beginner. We don't know how many beginners, so we've called it x because the problem told us to. $35 for advanced. We don't know the number of advanced, but we know there's 20 students total, minus x, which is our beginners. So there would be 20 minus x left over at $35 each. So now you're going to distribute and combine. So pause the video and simplify this expression into one simplified expression. Press play when you're ready to check your answer. So if you distribute, you end up with 35 times 20, which is 700. I just dropped down my 20x, minus 35x. My like terms are 20x, and keep in mind it's negative 35x. Those combine to get a negative 15x plus 700. So that would just be your expression. It did ask for an equation, so equals y. So that's going to be the equation that I'm going to use. So now for part B, I'm going to use that equation that I just came up with. Y equals negative 15x plus 700. And now it tells me that the number of beginners, which so far has been x, is actually 15. So instead of x, I'm going to replace it with 15. So I'm going to have y equals negative 15 times 15 plus 700. And that would be negative 225 plus 700. So to add a negative and a positive, I really subtract. So 700 minus 200 is 500, but then minus another 25 would be $475. So if 15 of my 20 students were beginners, I would make $475. I can check that using common sense by saying, okay, 15 are beginners, and they were $20 each, so I would make $300 off beginners. But if 15 are beginners, that would leave 5 for advanced, which is $35 each, which would be $175, and if you add them, you get $475. So you know, because this and this both come out to $475, you know that your answer to part A must have been right. The last part says, suppose you plan to teach for 10 weeks. Well, this right here was always assuming we only needed to teach for 1 week. So I'm going to take that, negative 15x plus 700, and I'm going to multiply it by 10, because I want to teach for 10 weeks. And my goal when I do that is to make $4,000. Now keep in mind that X still stands for beginners, but this is asking how many advanced students would you need to teach. So X is beginners, things that you want to keep in mind, you're teaching both beginners and advanced, and every week you teach 20 students. So just at the end that'll come into play. So I'm going to distribute my 10, negative 150x plus 7,000 equals 4,000. Going reverse PEMDAS to isolate x, so I'd subtract 7,000 from both sides, which gives me negative 150x equals negative 3,000. I'll just put that over here. And then the last step to getting x isolated would be to divide by negative 150. And negative divided by a negative is going to be a positive. I could cross off a 0, and 15 would go into 300 20 times. So what this is telling me is that in order to make $4,000 in 10 weeks, X would need to be 20. But remember, X is the beginning students, so I would need to teach 20 beginning students. And I'm only teaching 20 students a week, so that means that I would actually need to teach 0 advanced students. So to simplify these expressions, there's going to be a longer way. I'll do that over here. And then over here I'll show you the shortcut. So first I have 36x minus 24, and I'm dividing that by 6. So even though I don't see any fractions, I'm actually going to think of it like a fraction, which to divide fractions, so if I make 6 into a fraction, to divide fractions, you multiply by the reciprocal. So now I've turned it into a distributive property problem. So now I could distribute 1/6. My final answer would be 6x minus 4. So I could go through that process every time, or I could just look back at the beginning and say, how could I get from here to here without having to go all this way? So one way to do it is to just divide each. 36x divided by 6 is 6x. Because it's minus, I'd bring down a minus. And then 24 divided by 6 is 4. So I call this, sometimes I'll refer to it as the beans, and you can just divide them each. Just remember that you're dividing, and if you're ever unsure, they're separated by a fraction bar, and a fraction bar means division. So this doesn't say 36x times 6, it says 36x divided by 6. So make sure you're dividing, and that you're dividing both. So if you did that on this one, you'd end up with 5x plus 4. 40x divided by 8 is 5x. 32 divided by 8 is 4, separated by a plus sign. Try the remaining 3 examples. Pause the video, press play when you're ready to check your answer. If there are fractions involved, leave them as simplified fractions. Try to avoid decimals. So on this first example, you're dividing 2x by negative 4. 2 over negative 4, if you reduce that as a fraction, would just be negative 1/2 x. I also did leave change opposite. I made it plus a negative 8, so then I have my plus sign here, and I'm dividing a negative by a negative, which is a positive, so negative 1/2 x plus 2. Here I have negative 6y divided by 3, which is negative 2y, plus 18 divided by 3, which is 6. And here I have negative 10z divided by negative 5, which is positive 2z. Again, I made it plus negative 20, so that's my plus. Negative divided by negative would be positive 4.